the graph of secx, and this is 1 over cos. So to draw the graph, we just need to think about what the values of cos are and what 1 over it is. So of course, cos is equal to 1 here. Okay, so that's 1, and either side of this, cos is less than 1, so 1 over cos is going to be greater than 1, so we get this sort of shape. Terrible drawing, but you get the point. And when cos is equal to 0, we don't get a value. This will be here, so we get this sort of asymptote when cos is equal to 0. So we get that down here too. So if we think about the values on our graph, this is, let's say 1. These points here, these asymptotes, pi over 2, and then at pi, cos is equal to -1, so 1 over -1 is -1. And again, when cosec is greater than -1 but less than 0, 1 over cosec is greater magnitude but still negative, so we get this decreasing shape. This is pi, this is -1, and we get the same, completely the same symmetrical pattern on the other side. So secx is a very symmetrical looking graph. Again, this is -pi, and you get this pattern repeating, so we'd have another asymptote down here, and then we'd get one up here, and so on. So we get like a shape like that, and a shape like that. I mean, that's a terrible drawing, but that gives you an idea of the graph, and that just keeps going, another asymptote, another asymptote. Okay, so let's rub out the green lines here, and we'll put in some, then we'll draw the graph of cosec x, which is 1 over sine x. So hopefully you did see the last video and you've thought about these graphs before clicking on this, because the graph takes on a little bit more meaning if you've actually seen it before. I've missed a couple of points here. Okay, that'll do. So for sine x, well, sine's 0 on this y-axis, so this actually becomes a little asymptote. Okay, so we've got 1 over 0, and then sine's equal to 1 at this point, pi over 2, and then all we get is the same graph, just like how cos and sine are the same graph, just shifted up. The graphs for sec and cosec work exactly the same, so the asymptote just happens to fall at pi, and then the -1 value, so this is 1, this is -1, comes at 3 pi over 2. Okay, so it's just the graph shifted up a little bit. We get this sort of shape here, and we get another one here. Alright, so that's the sort of pattern you need to remember when drawing this, and just remember some of the key values. Here of course we've got -pi over 2, -3 pi over 2, and -pi here. So the key, if you do forget these, just think, what does sine and cos look like? We're finding the 1 over these at important values, so the important values are the asymptotes, these turning points, and then just remember these shapes you get. Finally, one that's a little bit more complicated, but it's not too bad, is cotx, and it's only a little bit more complicated because tan itself, the graph is a little bit more complicated than the sine and cosine graphs. Okay, and we can actually leave this asymptote on because cot of course has this, because tan of 0 is 0, so we get this asymptote here for cot for 1 over tan. And then what we get is we approach this asymptote, then we come down, okay, towards some point, we curl in, and then we have some sort of inflection point, and this is poorly drawn, and we get to this asymptote here. So pi over 2 is this intersection point, pi is the asymptote, and this shape repeats itself. So then we start up here, we come down, and we get the same sort of shape. So if we just draw on a little asymptote here for minus pi over 2, we get the graph coming down in and down this asymptote here. Okay, the asymptote's at minus pi, sorry, and this is at minus pi over 2. It's because if you think about the tan graph quickly, so x and tan x on this axis, we come up like this, a very similar shape, but now we've got 1 over tan x, so these get flipped over here, and you know, we get all this going on. But of course, like I say, when this is 0 we get asymptotes. When we have asymptotes on the tan graphs, we get zeros. So it's all these sorts of things that you have to remember. So those are the 3 graphs we wanted to look at. Yeah, just note my graph sketching abilities are not particularly brilliant, but as long as you, when drawing these things, you get the key points, you get the asymptotes, you mark them on, you get the turning points, you mark them on, you label your axes, you'll be sure to get full marks in your exams. So if you've got any questions on this, let me know down in the comment section below. If you did enjoy this video, please be sure to like and subscribe, and I hope to see you